we have another energy problem today. So, a 5 times 10 to the fifth kilogram subway train is brought to a stop from a speed of 0.50 meters per second and zero point 0.4 meters by a large spring bumper at the end of its track. What is the force constant K of the spring? So, immediately off the bat, we can tell that there is no gravitational potential energy here. There isn't like a change in height or anything. So, we can already rule that out, and then we can figure out that we have a kinetic energy because the train is moving, and it's also asking for K, so there has to be a spring energy involved somehow. So there are like different ways to set this up, but I typically prefer using like law of conservation of energy. So E initial equals E final. So initially it only has a kinetic energy because it's moving at a speed of 0.50 meters per second. So we can write 1/2 mv initial squared equals, and then at the end it's brought to a stop, but it has like a spring acting on it. So there has to be some energy from the spring. So we get 1/2 kx squared. So let's plug in all the things we know and then solve for k. 1/2 5.0 times 10 to the fifth kilogram times 0.500 meters per second squared equals 1/2 k 0.400 meters squared. And then if we solve for k, we should get, let me check, 7.81 times 10 to the fifth power newtons over meters. And like for the units, you just like figure it out from this equation, or you can just like remember it. So yeah, that's it for this problem.